Right. All right. I'm finishing up a few extra things that I've been doing for the past half an hour. So this is take two. It's gonna be a local. I'm gonna deploy after that. Take on the PCB session one. Um, go. Okay, perfect. So it's about so what I've built is the following. So I've built a bit of a it's a so what we'll do is we'll actually go to localhost, although it's probably now broken. Um, all right. So essentially, see, because they might actually. Okay, so it's now doing the build, and also we'll just go to the PCB fundamentals again. And so I've built a couple of things in here. Oh, it's messed up the monitor. Okay, let's see what it does. I want to make sure that it actually does it actually build. All right. All right, all right, all right. Cool. The rollback feature. Yeah, I'm gonna explain what I did. Okay, so and we can do a bit of a mini demo. So we can continue the session actually. Or let's do this. Let's reset. So let's reset. Okay. So now you have more control. I thought fine. We'll give you more control on what you're doing. So it's fine. I guess we can reset. So we can reset the probes. That's good. Then what do you already know? So we can flag things as done, like steps in the plan as done. And we've talked about this already, so we can mark it as complete as well. And we will now resume and so this is consider now how components get attached to a PCB and how there are different methods for that. So we know that as well. Let's summarize what you've understood so far about PCB components and functions. Does anything feel unclear? Let's do the checkpoint. I mean, that's okay. Let's do the checkpoint. And let's do this. So let me try to do a summary. Okay, so let's just check data input. The audio is working perfect. So the summary is the following, and I'm gonna be working on a few things later. But anyway, I get distracted. So the summary of what we know. So we know the purpose of the PCB. The purpose of the PCB is to get rid of the dangling cables. It's like a solid base and whatever. Now what are their components? So essentially, you have in a PCB you're gonna have multiple things. You have like a conductive layer where the electricity is going through. Then you're gonna have a mechanism which I don't fully understand why I don't remember exactly which one was correct, so we can go back to this later. But like a mechanism to define paths on this conductive layer, not cables, right? And then we have those vias, those holes, which this was something new that I learned that basically help you connect multiple layers, right? Which can be good for things like implementing complex paths where we're going sort of underneath. Maybe I'm just making it up, right? I'm making it up, but I think that's the way that's one of the utilities of the. But also accessing components that are on the other side and like that. There are PCBs, I guess, where you have like you know various sides to the thing. Um, what else? What else about the PCB components? And you have obviously connectors or things, interfaces to connect with the outside world with standard components like a USB thing or whatever. Then you also have support components which are basically there to make sure that, like, I think there's this ground layer, right? Where yeah, cool, awesome. We'll move on. How would you differentiate between through hole and surface mount PCB technologies based on their assembly and advantage? Think we can skip that. I mean, it's fairly simple. The differentiation is the through hole. So I think through hole is basically great. It has the advantage that you can probably You can probably, yeah, it's compatible with like legacy things like the resistors and whatnot with the like little cables. And I think basically the problem is that you can't scale down too much, right? um and still like they're probably easy for them to kind of like break and whatnot. It gets more complicated. You have to make more holes, I guess, right? And the surface mount PCB technology is probably much easier to automate. You can probably compress much more in one space because they're literally laying flat on top. Although maybe they have some differences in terms of the physics you have to consider when you do that. I don't know. Manufacturing these, maybe you can't put certain elements too close to each other and stuff like these. Um, I think that's really what it is. Are we done with these? I think so. How would you differentiate between through-hole and surface mount PCB technologies? Okay, since I'm unsure, perhaps comparing it to how wires work in a circuit and also touch on how multiple layers. Oh, that's a good point. That's a good point. How multiple layers might affect that. That's a good point. That's a very good point. Yeah. Of course. I think that's true. Through hole probably have the limitation that they only work for single layer or something like this. I think they only work for single layer while the other ones actually probably work for multi-layer, right? Because when you're making those pins, I mean, those pins must have a hole somewhere, right? We saw the image. Maybe that's one of the things that they do. They only work for multi-layer. But I'm not too sure about these. I haven't fixed the pause. Fuck you. No, I don't want to pause. I haven't fixed the pausing issue. Like, take a break. Take a 5-minute break. No, we're not taking a break. What else? And you're perhaps comparing it to how wires work in a circuit and also touch on how multiple layers might affect these. I mean, what else? I guess it's just in terms of the assembly that makes sense, right? So it probably has is a limiting factor on the layers, but I don't know how else I would explain that. Is it correct? I guess so. Um, Let me think, but I think that that makes sense. Yes, I think that makes total sense. And that makes sense. I don't know. I'm gonna mark it as complete. I mean, what else otherwise? Let me just think of this. How would you differentiate between through-hole and surface technologies? So the difference between through-hole and surface mount. Okay, so let's ask a real question. So the real question is, through-hole and surface mount. How do they impact? How do they impact uh, the design, or do they have limitations that impact the functionality of a PCB, or just design limitations? I guess it's yeah. I guess they had the. I mean, there's definitely a difference, right? So one is just sitting flat on top. How do the assembly process differ between through hole? Yeah, well, the assembly process, yeah, it's fine. I'm not interested in that. I'm gonna probably skip this one. The I mean, maybe it's just got to do with cost and see what the assistant actually comes back with. The assistant is slow, man, and it's too verbose down. But let's okay, so let's go through the through hole technology components have long leads, long leads or lead wires that poke through drilled holes in the PCB. They're soldered in the opposite side, creating a strong mechanical bond. Surface mount components are placed directly on the surface, no holes needed, and they are soldered using pads. Okay, fine. Yes, they are soldered using the pads. Think tiny chips without leads sticking out. Both can achieve similar electrical functions, but it just affects how you build and use the board. Size and density. Okay, we talked about these. Size and density, layering and routing. So THT often works well with single or double-sided words. Yes, but not for multi-layer designs. I mentioned that. So I think that is definitely, I mean, what else? Ease of assembly and repair. THT are beginner friendly for soldering. SMT are optimized for automation manufacturing. Yes. Electrical performance. THT components have longer leads, which can introduce more inductance or capacitance. Might cause issues with high frequency circuits. Mechanical mechanical environmental factors. Reliability and cost. Functionality isn't broken by either, but limitations show up in reliability. Okay, I think we're good with. So now you can just. I think we're good with these. I think we don't need to dive into these. But if we feel we have to go back to these, we can go back to these now because we have this extra feature where I can open one and just go back to that step in the plan, which I think it's actually helpful. Okay, so we're now on to the next one, which is basically draw a simple PCB schematic including key elements like traces, paths, and vias, and label them. We've done that. Okay, we've done that, but we can let's do that. What should I include in a simple PCB schematic to show traces, paths? I think that's still a bug. Is it still showing? Oh, no, that's different. Okay, that's a different question. Let me just go back to. So what do we have? We have basically what advantages might surface mount technology. Okay, we check that. That's all good. So how do the assembly process it? We check that. That's fine. What exactly does a via do to PCB, and how can it show in my sketch? Okay, let's focus on these. It's a good question. Let's focus on these two, or at least on the task. Or at least on the task. The task is to draw a simple PCB. I mean, how would you draw a simple PCB? I mean, the simple PCB would just be, again, I'm doing it like these, right? So we have this stuff here. Okay, so least basic stuff like substrate, traces, pads, bias, solder mask, seal screen. There's a lot of elements I'm not aware of, so let me just research a few of these. We have substrate, traces, pads, and silk screen. What are the substrate and the silk screen? Let's ask that. What are substrate and the silk screen in a PCB design? Yeah. So you see, I hope you're seeing the difference, right? I mean, this is really what we have here is an integrated learning environment. We have like an ILE, and then it's basically it has like a built-in loop, right? So it's actually guiding me through. If I let myself take through the questions and the guiding tasks, the idea is, that kind of guides my thinking, right? So that's the effect that I want to create with this, to help you, to train you actually learn, because reading on the fucking about quantum mechanics is not gonna get. Where were we? So awesome follow-up question. The substrate is essentially the foundation or the base material for the PCB. It's the insulating layer, non-conductive, that everything else is built on. Okay, so the foundation, that's good. Okay, so substrate is something that is basically the insulating layer, so the non-conductive one. It's what holds the copper traces, components, and other layers. Raw materials, most PCBs use FR4, which is a fiberglass reinforced epoxy. Stop with the fucking short breaks. I'm sorry. It's rigid, durable, and good withstanding heat. Okay, impact on design and functionality. So the substrate choice affects thickness, flexibility. It's fine. Functional impacts plays a big role in electrical insulation, preventing shorts. Thermal management, how well heat dissipates, and mechanical strength. Fun analogy. Do we go to imagine the substrate is a soil in the garden? Yeah. What is a silk screen or legend layer? Is the printed markings on the PCB surface. It's not about electrical connections. It's more like labels and artwork. Oh, nice. Okay, so the silk screen design uses ink, usually white or another color, to add text, symbols, components, outlines. How it's applied during manufacturing design. Doesn't affect the electrical function directly, but it adds to the board's real state. So my silk screen can clutter a dense design, especially SMT with tiny parts. It's yeah, okay. So functional impact is all about usability, and reliability impact is a good system, helps assembly. Showing where to place the components. I think these are these marks. I think if I look for a PCB, I think those are also these marks, right? This is the silk screen. I think also these things, yeah, this white stuff. I think that's what this is. All right. But I think that's working. I think that's working very good now. Uh, okay. I think I have to make it. I have to definitely make it less stupid. Um. Okay. So we have all these layers, functional impacts, fun analogy, whatever. Um. Sorry, we were back here. So we talked about the different. This is not okay. The substrate in the silk screen. Okay, I know. So I guess the schematic is, would you say that you kind of have, let's first draw layers, right? So you have maybe the substrate is blue, and that's where, that's the base. That's blue. That's the substrate, right? Substrate. Then you're going to have, I guess, a layer where you have the copper cables and whatnot. I think that goes underneath. Because then, so I think this is basically the paths, right? It's I don't want to take a break. Um some of these questions just, maybe there's a way that I can just force archive something at this. Force archive approach question. Stop suggesting to take a break. All right, so I think that's paths. That's the way that I would. So that's how I would logically think, right? So you first apply you first have the substrate. That's your like cookie. Then you have the paths. Then my assumption is that you have the silk screen, maybe here. I think that's where you have the silk screen. So this is the silk screen. Silk screen. And on top of everything, I guess you're just gonna have the components, right? Which is not really a layer by itself, but you're gonna have all the components. I think so. So this is the past, the traces. I think it's called traces, right? So they call these traces. The red is traces. Traces. And first at the bottom substrate, then the traces, then the silk, then the components. I guess the vias are just kind of through everything, right? Probably. And if you have a double-sided design, then you probably have also like the same thing here. You have like the traces here, then you have like more silk here, so you're just doing like a sandwich, right? I guess that's traces, paths, and well, paths. I mean, paths are here, right? So this is where you have the paths. I guess the paths is whatever supports these components, because are the paths the things that you connect stuff to, that you do the soldering? So are paths the plates that you solder components onto? I think that's probably what it is, right? Mm, mm. Okay, so traces, pad, substrate, solder mask. Okay, so there's a solder mask. Shut up with the feedback. Okay, so we have solder components, the small flat conductive areas on the PCB surface that attach and solder components to. Okay, we know that. And what is the solder mask? What is the solder mask? You know what we could have for people with attention deficit? We we can just have some nice rotating animation of something. Something that Grok generates like a video. That'll be cool. But I don't think I'm based on this. What is a solder mask? So the solder mask is a thin layer, usually green, applied over the copper trace. And it's not conductive. Okay. So the solder mask, does the solder mask go on top or underneath the silk screen? These ones keep coming back. I have to. This is so. What exactly does the via? I know these. Those time. Okay, so the solder mask goes underneath the silk. Yeah, the silk screen goes. Okay, so the silk screen. So there's still a solder mask. I'm running out of colors. There's still a solder mask on top here. That's a solder mask. So again, let's try to summarize this. See if mask. See if that actually is correct and enough to kind of complete the task. Because essentially we're done, I think, with the session, right? But so we have. Let's start from the bottom. So we have the substrate, which is basically the solid non-conductive element that is going to hold everything. That's where you're gonna, that's just the base, what makes it like hard. Then on top we have the traces layer, or the layer where we're gonna have the conductive paths. Then on top of these we're gonna have this solder mask, and then we're gonna have the silk screen, because the silk screen is just those annotations. So solder mask, the silk screen. The purpose of the silk screen is to do all the kind of markings and whatnot of things, and what components go where and whatnot. And then on top of that comes the solder mask. The solder mask is basically where you're gonna get all the stuff that is that is supporting the soldering of components. So essentially it's going to have the pads then on top of it, and then on top of the pads you're actually going to put the components. I think I'm not really missing anything here. I'm not really. Am I missing anything? Am I really missing anything? Maybe I should just have like button to force an evaluation. Not a bad idea, because I do feel like, what else? Otherwise, I'm pretty stuck. It seems like an issue about how current flows through the copper trace. Or trans. What am I missing? Oh, and the vias obviously are the holes that kind of connect the layers. But I'm not so sure. I'm not so sure I know what else am I missing. So what else am I missing from a layer lead perspective at PCB. Just give me bullet point. Because that would pretty much complete the base. Surface finish. Okay, so there's a few things. Drill. I mean, there's okay. There's a lot of technical. Copper layers and traces. These are the conductive paths. Yes, pre-preg. I didn't know these. Okay, pre-preg in multi-layer PCBs, insulating material like resin used to bond multiple copper layers. Okay, so this is for multi-layer PCB. So this means you have multiple conductive layers. Pretty crazy. Then you have vias or vias. Then you have drill mechanical layer. Defines holes for THT components. Drill mechanical layer. Then we have the solder paste mask. Stencil layer that specifies where solder blade is applied during assembly. The surface finish, which is thin protective coating. Keep out or routing layers. Brother, how many things? So the routing layers, design only layers in software to define no-go zones for traces components. Oh, okay, keep out. Also, that's just software layers. Assembly overlay layers, optional for nodes on component placement or testing points. Okay, so I guess we are also blending here the layers in terms of the actual physical layers of PCB and also the software layers when you're designing a PCB, right? And maybe that is the thing with the schematic here, right? So the task here says is like a PCB schematic. So you actually have all these different pieces, which are really virtual layers, right? Layers of information, like almost like when if you've ever designed an apartment or done something like this, you have like the different layers that you spec everything, right? And I think it's the same thing here. So what, and so what's the order? What's the order? Why is it going so slow? Do I have? Oh, I have. Okay. And what's the order of these layers? It's going sluggish. Going sluggish. But I think it's okay. I think I'm happy with it. I might actually yeah, I might come back to this lesson at some point, but I'll mark it as complete. I think I'm happy with it. There's definitely a lot of different layers in here. I'm happy with the way that it is. So let's see if it tells me what the order is, and then we'll wrap it up here. Okay. So I think we've completed session 1. I would say so. Because here it says checkpoint, yeah, hole, whatever. So substrate core, copper layers. Okay, good. That was good. Pre-preg. Yeah, drill mechanical layer, vias, solder mask, surface finish, silk screen. Keep out routing layers, solder paste mask, assembly overlay layers. Okay, that's fine, guys. We're done. I think we're done. We're done with the session. We're gonna end the session. What happens when you end the session? You end the session, it's gonna generate a summary for it. Actually, it's been a while without that. You don't have to mark, just it's all right. And this might not work. I mean, I don't know. Saving the session, and it should actually generate a summary as well. But because I'm on development mode, let's see what it does. Okay, so it actually hasn't generated the summary yet. It will probably this is done. Yeah, we can go back to that. I mean, that summary comes later with like a bit of an analysis on how you've done and all that kind of stuff. There's a bunch of data to analyze, so it probably will take. But it's like, okay, so once I'm in the results, I should show that it's on progress. I think that's a good feature. Once in results, show maybe a message. Come back later, or refresh. See the results. Because I think it's just that's. Oh, there it is. Okay, it just took a little longer. Let's read through these. I mean, it's a 26-minute session, focus on intuition fundamentals, the tutor use 6 probes to assess the guide, the student, blah, blah. Key gaps. So the primary gaps in the current flow through copper traces, often compared inaccurately to wires. Yeah, the multi. Okay, we haven't spent too much with the multi-layer effects. That's probably true. The components like substrate pads, solder masks, progress arc. Stay with the started with basic grasp. Early pros identified solid areas of resilience in returning after break. This is stupid. Okay, I have to find. This is too much. It's too much text. It should just be like strength, engagement, confidence, more visual aids and hands-on examples. Suggest the next step: practice sketching a simple PCB. Review and compare through a whole service, like current flow and basic circuit results using Tinkercad. I mean, we'll definitely do something like this, but I need to improve the prompt for the summary. It's not too useful. Should be shorter. And okay, guys, we'll wrap it up here. See you tomorrow.